Good morning students, welcome back to this Sheba online class. Today we go for that, the element name is phosphorus. We have done the phosphorus structures already in previous class. Today we have to continue this, the phosphorus properties uses as well. Okay, this is the properties of phosphorus. In this phosphorus, it's very poisonous. I am already explained about that. That is the poisonous one, and that is the kind of, what is that, the white phosphorus, and what is that, the red phosphorus. Okay, in this type of phosphorus, what will happen, react with oxygens. If the phosphorus, that is like, for example, the yellow phosphorus become to this red phosphorus, previous stage is the yellow phosphorus. Okay, in that kind of phosphorus react with oxygen, almost they react with air, which means we can get that phosphorus pentoxides. Okay, and then move on to this. Another one for phosphorus is, that is the red phosphorus. In this red phosphorus also react with air, we can get that the phosphorus trioxide as well. It's too about that the phosphorus pentoxides too. Okay, and that is that another properties for that phosphorus, it's react with chlorine, we can get the phosphorus trichloride as well the phosphorus, what is that, pentachloride. Okay, very good. And then move on to this next, the phosphorus react with alkali, that is that phosphorus PO4. So I have to write down for that reactions. Okay, notice that the P4 react with alkali metals along with the water molecules, we can get sodium hypophosphite, that is NaH2PO2, that is sodium hypophosphite, and PH3, that is phosphine. Okay, PH3 means phosphine, it is a gaseous state. And then go for that nitric acids. What will happen? It will be react with nitric acids. We can get H3PO4, phosphoric acids, and NO2, that is the nitrogen dioxides and water molecules. Okay, and another one, this it react with metals. What will happen? React with metals like magnesiums, calciums, and what is that? Yes, sodium. We can get that the phosphites. What is that? Phosphites means magnesium phosphites, calcium phosphites, and sodium phosphites. Oh, likewise the properties is there for that in our textbook. Okay, and move on to this uses of that phosphorus. What is that uses? Let's see that the phosphorus is used for that, particularly red phosphorus is used in matchbox, and then it also is production of the certain alloys. That means for example phosphor bronze. Okay, this is the main uses. And move on to this concept is, what is that? PH3. Yes, phosphine. The chemical formula is PH3. Okay, in this phosphorus is bonded with hydrogen bond. Okay, this is preparations for that phosphine. Its phosphorus react with the sodium hydroxide along with the water. We already noticed that for the properties of that phosphorus. Okay, where is it? Yes, sodium hydroxide and water. The same way we have to write down for that preparations for phosphine. So we can get that, what is that? NaH2PO2, sodium hypophosphite, and then the gaseous state of, what is that? Phosphine. Okay, this is the main preparations. And then the properties, and we have to learn about that another preparations for the important for that phosphoric acids, and it's decomposed, which means it's heated, we can get phosphoric acids, that is phosphorus, that is phosphoric. What is that different? You have to notice H3PO3, here H3PO4. If it is H3PO4, that is phosphoric acids. If it is H3PO3 means phosphorus acids. That is the main difference. And along with phosphine, the gaseous state. So that I mentioned for that the upper arrows. Okay, and the physical properties. What is that physical properties? We have to notice that the colors and that properties. It is colorless. In this phosphine is colorless and poisonous gas too, with a rotten fish smell. The rotten algina abdin solvangla, that is rotten fish smell. It's slightly soluble in water. It's not more insoluble in water. It's to be the slightly soluble in water. Naturally in litmus test also. It's condense to the colorless liquid in 188 Kelvin and freezes solids it's 139.5 Kelvin. So this is the physical properties of this, what is that, phosphine. And move on to these chemical properties. What is that chemical properties of the phosphine? It's decomposed of phosphine with presence of 317 Kelvin and presence of its current passed. It's to be current passed only we can get that phosphorus as hydrogen molecules. So this is that the chemical properties of phosphine. And this combustions. What is the reactions about the combustions is phosphine react with oxygen. Obviously combustions means react with oxygen. Decompose means it's react, the only one reactant is there for the decompose. You have to verify whether that is that what kind of reactions, displacement, combustions, and what is this, decompose. So you have to find out what kind of reaction is there. So obviously this is react with oxygen, so it's considered as the combustions reactions. So we have to get phosphorus and along with what is that, water molecules. In this what kind of phosphorus? It's phosphorus pentoxides. Okay, but we have to notice PO4O10. Here it's not a 5, it's 10. That is means the 2 times of phosphorus pentoxide we can write P4O10. That is P2O5. That is that phosphorus pentoxide. Here P4O10, that is also phosphorus pentoxide, which means it's 2 times of that element. Okay, and move on to this. The phosphorus pentoxides again react with water molecules. We have to get the product. So again in this reaction, it's move on to this. We can get metaphosphoric acids, that is 4 HPO3 and 4 molecules of waters. So this is the main preparations and properties of this phosphine. And move on to this basic nature and what is the reducing property as well as the structure of phosphine. Okay. So the basic nature is phosphine is weakly based. It's based on the weakly base and form of phosphonium salt, that is phosphonium salt PH4I, that is iodine. It will be react with hydrogen iodide. We can get what is that, phosphonium S salt, and along with the halogen acids too. So, and then reducing properties. For the reducing property, in the silver nitrate react with the phosphine, we can get that silver phosphide and nitric acid, that is HNO3. Okay, this is the properties of nature of phosphine. Now move on to the structure of phosphine. Okay, this is the structure of phosphine. In this phosphine, its phosphorus, it's bonded with the 3 atoms of hydrogen. You have to notice that phosphorus, it's bonded with hydrogen in this distance is 1.42 angstrom, and then have to notice the hydrogen to hydrogen, the distance, the angle is 93.5. So in this bonded with the 3 types of hydrogen, and in this the only one lone pair is there. So the structure of phosphine is there. For that it's also reducing, it has a pyramidal shape. Okay, and this is time for the reading of the uses of phosphine. The phosphine used for the producing smoke screen. I am going to explain about that phosphine, the very important uses, that is the ship indicator to this, the signals, ship varakudiya the distance or that the intimations, for that using the fog. அதாவது இந்த fog யூஸ் பண்ணிட்டு அந்த ஷிப் வந்துடைய டைரக்ஷன் ஸோ இல்லை எவ்வளோ டிஸ்டன்ஸில் வருது அப்படின்றது நம்மளால கண்டுபிடிக்க முடியும்னா தட் கைண்ட் ஆஃப் fog எதில் யூஸ் பண்ணுறாங்க அப்படின்னா தட் இஸ் த மெயின் திங் phosphine. How to be used to produce that smoke means it's produced, its container with a mixture of calcium carbide and calcium phosphide. It liberates a phosphine and acetylene when thrown into the sea. So in the 2 kind of compounds நீங்கள் மிக்ஸ் பண்ணுறப்ப உங்களுக்கு வந்துட்டு phosphine அப்படின்ற ஒரு ஸ்மோக்கியான ஒரு கண்டென்ட் வெளியில் வரும். ஸோ அது இட் வில் பி கிளியர்லி டு see that in even that long distance, so that the main uses are அதை சொல்கிறாங்க. ஓகேவா? and then it's also it's called what is that, harm signals, that is harm signals. Okay, and then for the next concept is phosphorus trichloride, that is PCl3. Okay, PCl5 means phosphorus pentachloride and this is phosphorus trichloride, that is PCl3. In this PCl3's preparations is phosphorus react with thionyl chloride, that is 8 molecules of SOCl2. We can get that phosphorus trichloride and what is that, SO2, and along with S2Cl2 sulfur chloride also we can get for the preparation of that phosphorus trichloride. Okay, and then move on to this properties. What is the properties of PCl3? If this PCl3 react with water molecules, we can get H3PO3. What is that? H3PO3, that is phosphorus acid. If there is PO4 means yes, phosphoric acids, and along with hydrochlorics too. Okay, and so many properties is there, you have to read out for that your textbook. And then for uses of the phosphorus trichloride, that is phosphorus trichloride is used chlorinating agent, and for the preparation of H3PO3, that is phosphorus acids, the preparation of chlorinating agent are the phosphorus, I mean the PCl3 play agudu. Okay ma? So that is also I want to explain about that, the structure of PCl3. In this structure of PCl3, it's bonded with chlorine. The distance with phosphorus and chlorine, that is the 204 parameter, and chlorine to chlorine the distance is 100 degree. Okay, that is the structure of that PCl3. And then preparations. Now move on to this PCl3 preparations. Okay, this is the preparation of PCl5, that is phosphorus pentachloride, that is react with chlorine, it's phosphorus trichloride, we can get that phosphorus pentachloride. That is PCl3 react with Cl2, we can get PCl5. And this is the chemical properties. In this chemical properties of PCl5 in gaseous state, we can get PCl3 and Cl2. That is that reversible reactions. You have to notice that it is a reversible reactions. And then PCl5, it's react with water molecules. What will happen? That is phosphoryl chloride we can get along with hydrochloric acids. And then again we have to implement to this water molecules of this product. We can get that phosphoric acids with hydrochloric acids. You have to notice that it can conclude for the overall reactions, that is phosphoric acids and 5 molecules of hydrochloric acids too. Okay, and this is for uses for PCl5, the chlorinating agent. This is the very good chlorinating agents and replacing hydroxyl groups of its by for only in chlorine. The structure of the P2O3, that is that phosphorus trioxide, that is oxophosphites. The structures in here you can see that the structures in this phosphorus is bonded with oxygen. We have to complete what, that is that chlorine react with the phosphorus, that is phosphorus trichloride and phosphorus pentachloride. Now move on to this oxophosphorus acids, that is that phosphorus, it's bonded the 3 atoms of the oxygen. You have to notice the phosphorus 3 atoms of oxygens. Okay, so this is the structures. It's bonded with the phosphorus with the oxygen is the distance is 165.6 parameter, and if it is the single bond, that is that parameter is 184. Okay, if the general distance is 165, for the compare it with the double bond and the single bond, that is 184 parameter for single bond. And the same way we go for the P4O10, that is phosphorus pentaoxides, that is 2 types of phosphorus pentaoxide we can write P4O10. I am already explained you for that, the name is phosphorus pentaoxides. In this bond also the distance is 143 parameters. So this is the difference between that phosphorus trioxide and phosphorus pentaoxides. Okay, then go for that, the next concept. For that concept is the oxoacids phosphorus structures along with preparations. So what is that preparations and what is that the structures, we will see that in your textbook. Okay, this is the oxoacids phosphorus structures. You can see the textbook for the formula along with structures, and also oxoacids phosphorus preparations too is here along with oxidation state, it's +1 to +5. The preparations we can get that for that phosphorus acids, we can get that H4P2O7 along with water, you can pyrophosphoric acids. Okay, so you have to students verify the textbook for the page number 72 and 73. Okay students, this is the concept of today classes. You have to read out very well, and as well as you send out for the homeworks as per the time. Okay.